low voltage smart grids. Thank you for your help.
Okay. Dear gentlemen and ladies, my name is Dušan Vukotić. I came from ODS, Operational Distribution System. I will first answer some questions that we discuss a little bit later, a little bit before, because security of the energy market is very, very sensitive. Before, I don't know, a few years ago, when we have a gas crisis, when actually we have a broken chain of the supply to the gas, then everybody will move on the electricity. And in this moment, we have very powerful distribution network in Belgrade, and we are able to cover all this problem of this debalance of energy global, because everybody in this moment, when we don't have any supply of the gas or the heating in the households, then we move immediately on the electric. And in this moment, it was very, very dramatic change in this moment. And we always, when we make a plan for the winter, we always calculated on this problem in this, maybe broken on this problem of heating, because we have very high sensitivity regarding the thermal heating in Belgium, because half of our domestic or customers actually heating by remote district system. And if system in Belgium for the district heating work perfectly good, except during the nights, we don't have any problem with energy or electric supply during our consumption area, and it's very good. Then we have very strong, and we still have a strong coordination between our two companies, and I believe it's cooperation very good. But we are very sensitive on this matter. And also we have a third coordination plant on our consumption area. This is a clinic center of Serbia. This is 1.92 megawatts electric power. This is gas motors, and also this is for the closed terminals, because we know all these sources because it's interconnected on our electric network, and it always must count on these sources must be connected on electric network. Let's go to our subject. The step toward to the optimization or smart grid low voltage network. We start on the beginning of the 21st century, then we very forced the make automatization of the electric networks in our consumption area of the city of Belgrade. And we actually finished all the automatization and covered all our primary and main substation with SCADA systems. You see on previous presentation that on the thermal plant level, they just cover a few of them SCADA system, actually on the thermal side. But we also in this plant, they have also electrical SCADA in some of these plants. But in our substation, we covered with 98% of all our substation of 110 kV, 35 kV. We are covered with SCADA from one main control center in Belgrade. This is currently our organization between 1.5 years ago. In this moment, we group in the little bit change organization. We group all 5 utilities in Serbia into one common company, what we call Operational Distribution System, ODS. And in regard to Belgrade, we still, because I'm in charge from Belgrade, we cover this area of 2,800 square kilometers and more than 1,700,000 inhabitants. Actually, we have 823,000 customers. When you compare with these customers for the thermal heating, this is actually half. When you compare, because this is twice more than these thermal heating suppliers. But when you combine about this energy parameters. Actually, we in Belgrade use the quota for total energy in Serbia, and this is our electrical peak. It's more in before we have this one peak record in 3 years ago. It's more than 1,650 megawatts. It's a little bit less than this thermal peak, but we combine with this multiplier, this is more than thermal plant. This obviously because with electrical network we cover all our consumption area. I will a little force up because we don't have so much time, but because this team is very wide and now is in focus because everybody is talking about smart grids. Smart grid is like in this moment like paradigm. This is something what everybody from the marketing level use like to explain everything. But smart grid is in this moment is a point of the technology because in this moment we are able to combine and make integration between the electrical and the IT resources what we have in our consumption area. Actually, obviously we have very old and this is a classic electrical network what we have and what we deploy in our network or our area, but also we have very impressive IT communication network what we build up and start before 30, 40 years ago, and in this moment we make a very hard, very strong effort to combine these two networks, one common like smart grid network. Actually, when I talk about with optimization of middle voltage network and high voltage network, we actually spend a lot of effort, and we actually in this moment on our consumption area we have about 2,000 closers and more than 130 substations that we covered with communication and be able to remotely control and operate and monitoring this substation. In this moment, or actually 1 year ago, we moved one step toward to the low voltage network, and this is a very step because we have on our consumption area more than 8,000, less than 7,000 substations, because in our owner it's more than 6,000 substations. In this moment, we have intent to cover all these consumption nodes with some electrical devices who will be able to remotely monitoring these points. Actually, our primary goal to reduce the losses. This is an aggregation of the technical and non-technical losses. In our case, when you compare, then we have maybe a little bit more than 5% of the technical losses. In opposite, we have more than 9% non-technical losses. This is something problem with our society, something what we primarily must solve it. But regarding the technical losses, we have very good parameters. All these parameters regarding safety, regarding the reliability, it's very good when you compare with another electric utilities, and we not have any gap between these parameters what we have in Serbia and Western Europe or Europe, wider Europe. But regarding the losses, we must a little bit on the non-technical, we must have more activities to reduce, because regarding the technical losses, it's very satisfying results, but non-technical, it's something not good. On the low voltage network, we have a dramatical, because this is a low voltage network, it's interconnection point between all these sources, what you have at homes, what you have in power plant, what you have in CHP, combined heating power resources, what we have DGs. And this is actually connection point when we exchange electrical energy between these actors on the market. Before 3 years ago, we started with project with automatic meter infrastructure, but we plan to install more than 2 million smart meters wide in Serbia. In Belgrade, we want to cover also these figures with more than 8,000 households. In this moment, we a little bit stopped this project because there is a really big step forward to this rollout must be very efficient. We have some area what we already covered with some smart meters. In our case in Serbia, we have more than 250 customers per one substation. It's, when you combine the figures, it's twice time more than in Europe. And when we must provide this very huge rollout maps to install the smart meters, it's not easy to in this moment. Then you cover, you have very bulk data and bulk activities, but when you install these smart meters, also concentrator in the substation, and then you put in progress all these components. On the other side, we have a problem to monitoring losses in the network, and our primary goal then we install this smart, we call meter cabinet, what we install on low voltage side of the substations, and our final intent then we these two devices, two different devices that we integrated in one devices, and then we have, because we have one common communication, what we install and what we provide for this purpose. In this case, this is one common schematics what represents actually interfaces between the SCADA system, AMI infrastructure, and also some components what we use for monitoring of network. Also on the left side you have smart meters, but also we provide the interfaces for integration of the meter for the water, for the thermal energy, and all these meters what we have in the homes. Actually, based on the communication standards and all these activities, we make some official or some common frame for integration of all these components. I know this is very critical regarding the time. I will just present. This is the one cabinet what installed on each substation. In this moment, we cover more than 350 substations with these cabinets, and when we and this is installation by the network. We group these cabinets on the middle voltage feeders and receive this data in the center, and every 15 minutes we collect this data and compare with consumption on the middle voltage feeders, and you can see this ideal overlapping between aggregation data what we earn from the consumption nodes and what we have during. The difference between red diagrams and green diagrams is actually, this is a technical losses. You can see this technical losses actually in the network it's low when we compare with the losses what we have on the non-technical side. This is some and this is also aggregation. Also, we have possibility to monitoring voltage profile, because voltage is very important if you want to manage with losses in the network. But also we must provide all the conditions for all the customers on network must be equal, and this reason we can easy to identify what is the problem and on which nodes we have problem with regulation of the voltage. This is some sample on the rural part, and this is what we have also in on the low voltage side. It's very critical. This is the unbalanced consumption we have on low voltage network, and we now make a lot of plans how we reduce these losses, because when you compare these losses share a lot of take a lot of shares of total losses what we have on our consumption area. This is something what also we following the power factor of our energy. Also we can use this system for following harmonics, and this is actually one architecture. this is architecture of our system. We use GSM network, and we provide very good contract with our one of communication provider operator, and based on cybersecurity, DMZ zone, and all these cybersecurity features, we provide a very high level of security, and because we integrated this data directly with SCADA system. This is also this is a very modern devices. They have very huge internal memory with Ethernet plug-in socket, and internal have all these important I/O inputs what we want to collect from our substation, and this is something what really provides very, because we spend a lot of time to make one strong technical specification for these devices. Finally, we done. Based on this specification, we going into a tender procedure, and on the market we choose the best solution. At this moment, this is the best ratio of the price and the technical characteristic of this device. And this is a strategy of the implementation of these devices in our network. In this moment, we finish this all the three phases what I present on this slide. In this moment, we finish this total amount of 350 units. In the next year, maybe we a little bit stop, because we earn a lot of data from the network, and now we must a little bit take a time to analyze all this data. But we already have a plan for the maybe next 300 units in the next year. And also we integrated with the GIS system. All this network is covered with our geographic information system. All these lines on low voltage side and middle voltage side we have actually topological graph what is the end of our customers, and it's very easy because we have topology. It's very easy to identify all the losses, and we have special application to calculate our losses, and very easy to identify where we have a problem, and we focus to find these drifts on the field. And one of the study, but we a little bit integrated these devices. Then we install thermical picture on the transformer. We add one new micro IRTU on the same cabinet, and we able to measure the temperature of the oil in the high point of the transformer, and also we measure the temperature ambient, and based on this we calculated hot pot on the transformer. Based on this, we be able to really following the consumption of the transformer. We installed this on the 10th substation. We finished last week study and adopt this study. Our Institute of Nikola Tesla present the results, and we finally adopt the results. But we will progress this mechanism to install in at least 100 substations in the next 2 years. And this is really real-time data. It takes time, but I don't have so much time because I want to leave the others participate to present data. This is something what we install on voltage side. We have very impressive plan to move a little bit step actually until the customers, because with the smart meters we cover connection point with customers, but this distance between the low voltage side and the middle voltage side, we will install these devices and we cover this gap. And in the future, actually, this is one of the smart grid solution what we expect to solve a lot of problems. In this moment, we have very good results, and we're not having that to be going toward to the low voltage side. Thank you.
Okay. Mr. Vukotić. Any question from the audience?
Do you think about accumulation in small grids? Because you have big changes in consumption. And what about accumulation?
Okay, about accumulation. I not open a lot of, we have a lot of features what we want to install. Actually, when we work on this study, Mrs. Nikola Tesla suggests that we on every roof of the substation install some solar panel and to cover the losses on transformer. But also about accumulation, we not have on our consumption via electric vehicle. And this is something what we expect in the future. We spend a lot in some studies. We just start to calculate it and to see what will happen when we have 5%, 10%, 50% of the I believe electric vehicles, because electric vehicles also could be storage and used to store the energy during the night, because everybody went back to the home after work. Then we start to plug in. After a few hours, you will fill the batteries, but after that, you will use like storage. In this moment, we not have any batteries on the low voltage sides. We not have these initiatives to install them. In this moment, we just calculated to install solar panel on our facilities. And this is just in the case to cover the losses.
Thank you. Thank you. I would just use this offer to offer you to use our district heating system as accumulator, with accumulators and heat pumps. It's very new solution, so think about it. And we don't have enough times, but short question from Mr. Božović. Just
the story about implementation of automatic meter reading system and replacement of old electricity meters with new ones is all about some 12 years at least. And now you have provided us some information that only about 1% of all households in Belgrade are covered by new electricity meters. So you have stated that some 8,000 of electricity meters were implemented.
This is on the 26 consumption area. When you multiply the 26 with 250, this is a total amount what we cover in Belgrade regarding the domestic. But our focus then first we cover with AMI infrastructure to cover commercial customers, because the share of this consumption is about 1/3 of the total consumption.
Okay, according to your view, what are the main obstacles in the faster implementation of automatic meter reading system?
Okay, there is a little bit, this is a problem with tender, because everybody talking about interoperability of the smart meters, but this is really not true. If you want, for us it's very hard. If you want to install smart meters, you must install from the one vendors. You're not able to share with different smart meters on the same consumption area, because you have one consultant who earn all this data.
But what about interoperability?
Mr. Božić, can we proceed? We will have another opportunity to speak about this, because you are a regular guest. So let's leave some topics for the next, please. And Mr. Vukotić.
During the lunch, we will continue.
Mr.
Till we are going to eat, you can discuss.